In March of 2020, global society was locked in a state of paralyzing anxiety. Billions of people were isolating in their homes, watching a highly contagious respiratory virus shut down the modern world. Right as that first wave of lockdowns took hold, a localized medical event occurred in China's Yunnan province. A worker traveling on a chartered bus suddenly collapsed and died. Post-mortem testing confirmed the cause of death was an infection from a pathogen called Hantavirus. Almost instantly, news of the incident caught fire online. Driven by social media algorithms that prioritize threat-based content, the hashtag Hantavirus began trending globally right next to COVID-19. Headlines framed the event as a new virus emerging from Asia, ready to trigger a second pandemic. But the virology told a completely different story. Hantavirus was a known pathogen scientists had been studying for decades. More importantly, the victim contracted the illness through environmental exposure to rodent waste before ever boarding that bus. The other 32 passengers were in no danger because the virus lacks the biological machinery to spread through the air from person to person. Psychological studies from this period suggest that the chronic stress of quarantine lowered the public's cognitive threshold for evaluating risk. This created a feedback loop where context-free data was treated with the same weight as a global emergency, sparking widespread alarm over a pathogen that had no physical way of spreading through the crowd. To understand why hantavirus isn't a pandemic threat, look at how it actually moves. Human infection almost exclusively requires direct environmental exposure to an animal host. The virus sheds in the saliva, urine, and feces of infected small mammals, and people usually contract it by inhaling those aerosolized particles while sweeping out a dusty shed or clearing brush. Once inside the body, the clinical impact depends heavily on geography. Old World strains, endemic to Europe and Asia, primarily target the renal endothelium, causing severe acute kidney damage. However, New World strains, localized to the Americas, attack the pulmonary endothelium, resulting in hantavirus pulmonary syndrome. In the lungs, the virus doesn't actually destroy the host cells it infects. Instead, its presence triggers an overwhelming, dysregulated immune response. The body attacks itself so aggressively that the blood vessels weaken, and fluid rapidly leaks out of the capillaries, flooding the tiny air sacs of the lungs. Western medicine currently offers no universal vaccine or definitive cure for this pathogen. While doctors often administer broad-spectrum antivirals like ribavirin, clinical trials show the drug is largely biologically futile against the pulmonary syndrome. By the time a patient struggles to breathe, active viral replication has already peaked. The life-threatening damage is entirely driven by that runaway immune system. Historically, outbreaks of the disease align closely with massive ecological shifts, not human movement. During the 1993 Four Corners Outbreak in the American Southwest, a sudden cluster of lethal respiratory failures was traced directly back to a spike in the local deer mouse population. Unusually heavy rainfall had produced an overabundance of piñon nuts, pushing a booming rodent population straight into human dwellings. So while the virus carries an agonizingly high mortality rate, it remains strictly anchored to the environment. Without an infected rodent nearby, the chain of transmission reaches a dead end. There is one virological exception to this rule. Deep in South America, the Andes strain has evolved a distinct capability. It is the only hantavirus proven to pass directly from one human to another. The danger of this specific strain was tested in the spring of 2026 aboard the cruise ship MV Hondius. A passenger who had been exposed to rodents in Argentina reporting developed a severe fever. Over the ensuing weeks, the infection spread to close contacts, including the ship's treating physician, eventually claiming 3 lives within the confined quarters of the vessel. News outlets immediately seized on the story, drawing direct parallels to the early days of the COVID-19 pandemic and painting a picture of a quarantine scenario involving a highly lethal pathogen. This node comparison shows the biological reality that health experts use to counter the alarm. SARS-CoV-2 is highly stable in airborne aerosols, allowing a single individual to infect dozens of strangers sharing a poorly ventilated room. The Andes virus lacks those respiratory mechanics. Human-to-human transmission is rare and requires exceptionally close, intimate, and prolonged contact, typically restricted to immediate spouses or medical staff performing invasive procedures. Because the virus has an incubation period that can stretch up to 45 days, health ministries had to execute massive contact tracing efforts. Passengers who had disembarked weeks prior were tracked down and placed under strict month-and-a-half-long quarantines. This maritime outbreak proved that while the Andes strain demands aggressive containment, its reliance on intimate contact acts as a biological bottleneck. The virus is a severe hazard, but it lacks the evolutionary mechanisms required to achieve exponential spread across a general population. While cruise ship evacuations and desert spillovers capture headlines, public health officials are shifting their gaze to a more immediate threat: our own urban centers. Large-scale construction projects are physically displacing subterranean habitats right under our feet. Combined with extreme heat and sudden urban flooding, stressed rodent populations are increasingly seeking refuge and resources inside dense public housing estates and commercial food centers. The data reflects this closing gap. In early 2025, Singapore's National Environment Agency recorded a 48% surge in detected rat burrows across the city, averaging thousands of active nests every 2 months. Eradicating these reservoir hosts is practically impossible. Urban brown and black rats possess highly advanced spatial memory to avoid traps, and a single female can produce up to a dozen pups every 8 weeks. Consequently, environmental agencies are pivoting away from reactive extermination. The focus is now on strict upstream enforcement, heavily penalizing improper refuse management, and repairing structural defects to cut off the food and shelter that sustain these reservoir populations. As urbanization and climate change continue to erode the boundary between human and wildlife habitats, localized zoonotic spillovers will become more frequent. Managing these rising risks requires 2 distinct lines of defense. We must fortify our urban ecosystems by removing the physical attractants of disease, and fortify our information ecosystems by vetting viral headlines with the same